Hey guys, today we're going to take a look at maximum and minimum values on an interval. Okay, so the first thing we're going to talk about is local maximum. So what this means, we've got ourselves a function. Okay, it has what we call a local maximum, sometimes called a relative maximum, usually called a local maximum, at a value of x if there's sort of a peak, okay? So we'll just say there is a peak. Okay, if there's a peak in the graph, then this is what's called a local maximum. Anyway, so you think of like the top of a parabola or something like that, would be a maximum value. Okay, so so the f of c, the value we get, is called the maximum value. Maximum value, and the point itself is just called the maximum point. Fairly straightforward. Okay, similarly, if we have a valley, it is called a local minimum. So if there is a valley. Okay, so in this would be called the minimum, a minimum value, and it would be called the minimum point. Okay. So then we have what it's called the global maximum. So actually I kind of lied to you when I said the parabola, because of course that would actually be a global maximum, because that is a maximum value that is the largest maximum value on the function. Okay, it's a maximum value for which no point is greater than. Okay, so there is a max value which no point is greater than. And it's not enough to say that no maximum value is greater than, because of course if we had a function that then goes off to infinity, well then that's not a global maximum, because there's a lot of points higher than it, even if there is a peak. If there's a peak and then it goes down and then it goes back up and it goes off forever, then that's not a global maximum, that's just a local maximum. Okay, so this is just called the global maximum value. Maximum value, and that is called the global maximum point. Okay, and similarly we have the same rules for minimum. So there is a minimum value which no point is less than this time. Okay, and this would be called a minimum, or this would be called a global minimum value and global minimum point. All right, so there we go. So let's talk about extremum or extremum. I don't actually know how to pronounce this word. I've never known how to pronounce this word. I've heard it pronounced multiple different ways. We usually use extrema or extrema. This one, I don't know which one is the proper way to say it. but whatever. So what it is this is all, the extrema are all local or global. Oh, that's not how you spell global. Max or minimum values. Okay, any of them. Doesn't matter if it's local or global, maximum or minimum. These are extrema or extrema. Okay, critical points. Okay, so critical points, first of all, it includes any extrema or extrema. I really wish I knew how to say that word, but it's a terrible word anyway. So any of those are critical points. The other points we have to include are, if it's on an interval, then you'll have a starting point. And we'll have the ending point. And the ones we're looking for today will all be on an interval, and so those points will be important. Okay? So we have an algorithm to find any of these points. Okay? So we're going to follow these steps, and again, so you'll notice this is over an interval. So I'm saying over the values of x, a to b. You'll notice it's square brackets because we are including those points, and that is important. We're going to find the global extrema. So this is we want to find the absolute highest point and the absolute lowest point. Okay? All right. So what we're going to do, number one, is we are going to find all x values. X values such that, you ready? Here comes the magic. What we want is we want to be able to find the derivative and set it to 0. You find all x values that satisfy that, and that's going to find all of the points where the slope is equal to 0. In other words, you're finding all the turning points. That's all the points where it starts to go, or it starts from going up, the slope's going up, it's increasing, and then it starts decreasing. Or in other words, the actual function is going up, and then it starts going down. So at that point where the slope is equal to 0, that's going to be all of the turning points. Okay, so once we find that, we know that our maximum values and our minimum values have to either be at those points or at the end points. So what you're going to find, or so what you're going to do, is you're going to, you're going to evaluate f of x, not f prime of x. This is not the derivative. Okay, so you're going to evaluate with the original function for a, b, which are the end of the intervals, right? From the starting and from the end, and any x values where f prime of x equals 0. Okay? So those are the ones you found in step 1. So using these x values and using these x values, you're going to sub all of those into f of x and find out what they give you. Okay? Once you've done that, whichever one is biggest would be the local, or would be the global max. Okay? And whichever is smallest, I'm going to get lazy, whichever is smallest would be the global minimum. All right, and that's all there is to it. Okay, so let's flip our page over here. Now let's take a look. So first of all, before we begin with the actual algebra ones, I want to look at this graph here. And we're going to talk about which are, it's a little fuzzy. Maybe that's as clear as I can get it. Anyway, we're going to talk about which ones are maximum points. So first of all, what you're going to do is you're going to say, well, this is a maximum point, okay, because it's decreasing after and it doesn't stop. This one's a maximum point, obviously, and this one's a maximum point. Okay, so if I was looking for the global maximum, it's just whichever one is the highest. So this one is global. These two, I need a new color, yellow. Okay, these two here are local. Okay? If I go to look for minimum points, that's a minimum point, that's a minimum point. E is not. I think they just put that there to sort of confuse you. But whichever one is smallest, which is obviously this one, that's going to be your global minimum, whereas point D is your local. Okay? So we can just say we've got local max, global max, local min, nope, global min. Okay. So my local max were, what did we have? We had A and we had C, and point F was our global. For minimums, we had a local minimum of D and we had a global minimum of B. And there we go. Okay, so now we're going to do one with algebra because looking at graphs is boring. So you're going to start, first thing we do, so we're going to follow that algorithm. So the first thing you're going to do is you're going to find the derivative of this function. So f prime of x is going to equal 12x to the 3 minus 12x squared. Okay? We're going to let f prime of x equal 0. We're going to get 0 equals, and I'm going to actually just start factoring this. I'm going to say 12, and then we'll have x squared. I'm going to be left with x minus 1. Okay? So there we go. So from that, I can tell you that x has to either equal 0 or positive 1. Now my interval was -1 and 2. Okay, so what I need to do, I need to find f of -1, and I'm just going to go from smallest to largest here. It doesn't actually matter, but I'm going to do like that, that, and that. So these are the 4 things that I need to calculate then. Okay, because I just discovered that these two here were, well, those are there, and these two here are there and there. Okay, so those are the 4 we have to calculate. So remember, you're using the original function here. So if I do -1, then I get 3. I should have given myself more room, but the -1 to the 4 minus 4 to the -1 to the 3, and that will give us 7. Okay, we'll do 0. This one's fairly easy. I'm just going to go straight to the 0. Okay, it's 3 times 0 minus 4 times 0. And then we've got 1, which gives us 3 minus 4. So I'm just going to go straight. Just because I'm out of room here, I'm just going to sub that in. I think that you can see that that equals that. And then finally 2, which is the most complex anyway, minus 4 is 2 to the 3. Okay, so we get 3 times 16 minus, oh, I'm just all over the place, 4 times 8, and that'll just give us 24. Okay, so if we zoom out, so we've got 4 answers. Okay, we want to find the biggest, which is right there, and we want to find the smallest, which is right there. So we can say, therefore, the global max is, and that was at, remember, you will need to give the coordinates here. So you have to give me the x value and you have to give me the y value. Okay? And then we say the global min is, and what do we have? We have 0, -1. And there we go. All right. So let's look at another one here. This time I'm going to give you a more challenging function. You can see we got ourselves a quotient, so we're going to have to use our quotient rule. So you have to think back to last unit. All right, so again, so to begin with, we're just going to find the derivative. Okay, so we'll have 2x, using quotient rule, 2x, x squared plus 1 minus x squared minus 1 times 2x, and the whole thing is over x squared plus 1 squared. Now do not expand that bottom because it's actually going to be irrelevant. We can disregard it down the line. So remember, never expand your bottom on the, especially when you're doing the quotient rule, until you know that you have to, because often you do not have to. Okay, so let's see. So we're going to expand the top though and collect like terms. So we'll have 2x to the 3 plus 2x. We'll have minus 2x to the 3. And then plus 2x. Okay, and then the bottom again, just leave it how it was. Okay, you can see that are going to cross out, and we're going to be left with 4x over x squared plus 1 squared. So this is where you can see it was important that we did not expand the bottom, because we are going to say let g prime of x equal 0, in which case the only thing that needs to equal 0 is the top, in which case you can see that x is equal to 0. Okay? So that was it. We only had the 1. So that's rather convenient. So this time, when we do this, we're going to find, hold on, we're going to find g of -1. We're going to find, give myself a room this time, learn my lesson, g of 0, and we're going to find g of 3. Okay, so let's just sub those in to the original equation. So we'll start with -1. So -1, so we get 1 minus 1 over 1 plus 1, so it's just 0. Okay, then we sub in 0, and we'll get -1 over 1. I'm just going to ignore that. And then we get 9 minus 1 over 9 plus 1, which is 8 over 10, or 4 over 5. Okay, so then we just say, what's the biggest? And what's the smallest? So, the biggest one, well, we got 0, -1, and 4/5. So that's the biggest. The smallest is going to be the -1. So we can conclude the global max is 3/4, and the global min is 0, -1. All right, and there we go. All right, so there's one last one. You can see it looks rather challenging, which is why you are going to complete it on your own now, and we're going to take it up at the beginning of class. So until next time, go Sabres!